Hello guys, welcome back to my new video. So today we are going to solve the question which is finding longest strictly increasing or strictly decreasing subarray. So this is today's Leetcode question. So yeah, as you can see that this is marked as easy and ये बहुत easy question भी है मतलब brute force solution भी आपका पास हो जाएगा because the constraints are in such a way that you are able to pass this with the help of brute force approach also. So let's see what we have to do. So we have given an array of integers nums, okay, and return the length of the longest subarray of nums, which is either strictly increasing or strictly decreasing. Okay, so let me go through with the example. So we have given an array of integer which is nums, and we have to find the longest strictly increasing or strictly decreasing. Strictly increasing means, can we say that 1, 2, 3 is strictly increasing? Yes. Can we say that 1, 2, 3, 4, 4, 5 is strictly increasing? No. Why? Because strictly increasing means every element is greater than the increasing means if I am talking about index I and j, then the previous element should be less than the next element, not less than equal to. And the same as strictly decreasing means 4, 3, 2, 1 is strictly decreasing, but 4, 3, 2, 2, 1 is not strictly decreasing. Understood? So let's see the given example. So in this, what we will do, we will first find all the possible subarray, and from that subarray we will check whether this is strictly increasing or strictly decreasing. If any one of the condition is true, it means it's either strictly increasing or strictly decreasing. Then we will find the length and we will keep taking of the length of the subarray, and at the end we will return the maximum length. So if we are talking about the possible subarray for this, then the possible subarrays could be 1, 1, 4. If we have 1, then we are checking, is it is strictly increasing? Yes. It is strictly decreasing? Yes. Then we'll keep answer which is 0, which is restoring the maximum length or the longest subarray's length. So we have currently 1, so length is here 1. Now we are moving for the next subarray, so which is 1, 4. Now we are checking, is it strictly increasing? Yes. So what is the size then? Till now the maximum size is 2. Now we are checking 1, 4, 3. Now we are checking, is it strictly increasing? No. Is it strictly decreasing? No. So our answer will be as it is. Now 1, 4, 3, 3. Is it strictly increasing? No. Strictly decreasing? No. Answer will not change. 1, 4, 3, 3, 2. The same thing. Now let's move to the next part. 4. Strictly increasing? Yes. But length is 1, which is not the current maximum. So we will not update this. We'll only update this if we are finding the longest subarray. Then 4, 3 strictly decreasing. Yes. Yes. Is it strictly decreasing? Yes. But can we say that the length is greater than the current length we have till now? No. Then 4, 3, 3 strictly increasing? No. Strictly decreasing? No. Then 4, 3, 4, 3, 3, 2. No, because these both are the same. Like that, if we are finding, you will have to update the answer if you are finding the greater length subarray. Okay, now let's see with this example. So here we have all the possibility in terms of 3, like 3, 3, 3, 3, 3, 3. And as I mentioned earlier, strictly increasing or strictly decreasing means the next element is either greater than or either smaller for each of the case. So here the next element is equal to. It means we can't have the length of the longest subarray greater than 1. So that's why here our answer is 1. So what is the approach to solve this problem? Yeah, is the way you are thinking is correct. Means the first approach that comes to your mind is correct. What we are doing, we are finding all the possible subarray. Okay. Now we are checking one condition. If subarray is two possibilities are there, either strictly increasing or strictly decreasing. Okay, then we are updating the length. Okay, and so what is the updating the length means? Our maximum length. Updating the length with maximum length, and at the end return maximum length. Okay, if we are talking about the code, so let me show you the code. Okay, so the same thing I did here. Our uh, this is the input function which is given. Now this is finding the size, the answer which will store the maximum length. Now using the to loop, I am trying to finding the subarray. Okay, so now what I am doing from I0 to n and j from I to n. Now I am checking if nums from I to j is strictly increasing, and the other case which I am doing is whether uh, nums which is from I to j is decreasing. If either of the case is true, then we are updating our answer. Understood, and at the end we are returning the answer. So for the finding the length, we are checking that for length is from j minus I plus 1. Yeah, this is easily understandable. And what the function I wrote for this increasing and is decreasing. So if it is decreasing, it means that if we are finding any case where our next element is greater than previous, it means it's not strictly decreasing. Then we are returning false. The same case for this strictly increasing. If strictly increasing means our next element should be greater than, but if we are finding that our next element is less than previous, it means it is not, then returning false. So yeah, this is all about the code. This is all about the approach. The worst case can be for this is order of n. The worst case for this can be order of n, and this will take order of n square time. So overall, you can say that it is taking around order of n cube time complexity, but it will pass as the constant are for n equal to 50. So if you like this video, then do like